So on this part video, I'm going to talk about cooling curve. Now, when you start to create a cooling curve from the cooling curve from scratch, you always need to remember temperature is on the y and the time is on the x, or the heat removal will be on the x. Okay, and cooling curve, you have two things you need to determine. One is you need to find make sure that it was cooling down. So initial temperature must be in high position. That means you're going to start the temperature on the high, and then your final temperature will be low. So because you're cooling down, so you would imagine the temperature will be going this way. But honestly, they're not like straight line. They're gonna be like a staircase. Another thing you need to know that is cooling should be from gas to liquid to solid. All right, so we first, how to draw the curve is we got to draw three slants. So we draw one slant and then skip to the right, second slant, skip to the right, and then third slant. Okay, so we're going to maybe extend the graph a little bigger. Okay, and the three slants, you got to label that with the three states. We say gas to liquid to solid. So gas to liquid to solid. And then if you want to ask about like what happened in terms of temperature, so then they are all cooling down. Okay, in terms of temperature. Actually, I'm not in terms of temperature. In terms of what happened to the molecules. Okay, in terms of what happened to the molecules are all cooling down. And then in terms of temperature, the temperature, they are all decreasing. Temperature decreasing. So you usually have three things you want to talk. One is the states of the matter. One is what happened to the molecules. Okay, they're cooling down, they're warming up, or they phase change like melting, condensation, freezing. And one last thing is the temperature going down, like decrease, increase, or stay the same. Now, after we finish the three slants, you want to connect the two flat. Okay, so the two flat, we said if this is gas, this is liquid, then in the middle will be gas and liquid. If this is liquid, this is solid, then the middle will be liquid and solid. Now you can notice that the temperature is not going all the way down. Even though you continuously remove the heat, there's an area that the temperature stays the same no matter how much time, like no matter you continue to take away the heat from it, the temperature stays the same. And where the temperature stays the same is actually phase change. The temperature stays the same is phase change. And they also have two states of matter. Okay, so here gas and liquid, they undergoes a phase change. I believe it's a condensation. Right, condensation. And then from liquid and solid altogether will be freezing. Okay, so these two flat area, they will have two states of matter, and the temperature stay the same. So right here we can write temperature stay the same, and temperature stay the same. Okay, so again, how do you gonna review is the three slant area, only one state of matter, one state, and the temperature go down, in decrease, go down, and they all cooling down. But the two flat area will be two states of the matter, and they're doing phase change, right? Condensation, freezing, and the temperature stay the same. And one last thing you want to label is condensation. We have condensation point, and the condensation point Cp is usually at the beginning of condensation. Now, even though this point had the same temperature as that, we don't want to label that it's a condensation point, because condensation point must be the point before you start condensation. Like the molecules reach the condensation point, that's why condensation starts. So never label at the end, must be labeled at the beginning of the phase change. Now, same thing here, freezing point will be at the beginning of freezing, which is Fp right here. right? So that's all you have.